Welcome students, this is your video for 10/28. It's going to be the Tuesday after you guys are off on Monday. Our lesson is on function notation and evaluation. We mentioned this word the other day, just a new way of writing things. In evaluation we've done a little bit of. Evaluation just means do the math. Okay, so it means plug in numbers and do the math. Let's jump right in. For function notation, we're replacing the y in the equation is replaced with f of x. Now this doesn't say f times parentheses x. This is f of x, just like it's written right here. It stands for a function of x. An example is y equals 2x plus 1 becomes we take out the y and we replace it with f of x equals 2x plus 1. And it doesn't have to be f of x. You're going to see problems where we do g of x equals 2x plus 1, or even h of x equals 2x plus 1. So there's a lot of letters that we can use for there. F is just the generic one that we typically use. Alright, we're going to rewrite the following equations in function notation. So the y gets replaced and it becomes f of x equals 5x plus 3. Sometimes when it's in a real world situation, like number 2 here, C would stand for cost and N would stand for the number of something, number of days or something like that. This one could be written C of N equals 3N minus 100. The key is whatever letter is here has to be the letter inside of the parentheses. Okay? This one could also be written as just F of N equals 3N minus 100 as well. Okay, so we could just do it a generic M, or F, but since we know that it's cost, we can go ahead and use the C as well. On number 3, we could do it M of P equals 2P squared plus 3P minus 4, or we could do F of P and do the same thing. So that would work as well. Okay? Evaluate a function means that you plug a value in for x and you solve, you do the math. Okay? So F of 2 when f of x is equal to x plus 5 means we're going to take the x out and we're going to put 2 in its place. And so if we come down here, f of 2, the 2 gets put in its place, 2 plus 5 is 7. And so that's a real basic example, but that's all you do is you just plug in and do the math. Alright, we're supposed to do f of 3 for all these, so they become f of 3 equals to replace the x with 3 plus 1, 2 times 3 is 6, plus 1 is 7. And this is kind of the old school way of just plugging stuff in, and we've talked about that in class before. We have newer school ways of typing in the calculator, and we're going to talk about that here in a second. On number 2, f of 3 equals, you still got to have the negative. You put what you're plugging in parentheses, so the opposite of 3 minus 3. Well, the opposite of 3 is negative 3, minus 3 is negative 6. Okay. The next one, f of 3 equals 3 squared, so anywhere there's an x, we're basically putting parentheses. Plus 2 times 3 plus 1. Now this one's going to take a few steps here. I do the 3 squared is 9, 2 times 3 is 6, plus 1, and so I'm just doing my order of operations. 9 plus 6 is 15, plus 1 is 16. So if I plug in 3, I get 16. If I plug in 3 on number 2, I get negative 6. On number 1, if I plug in 3, I get 7. This is how we do it in the calculator. I want you to do this first thing when we get to do this in class. I want you to do it first thing. As soon as you pick up your calculator, I want you to start working on these problems. And if I see you doing that in class, then I'm going to give you bonus points because I know you watched the video and you paid attention. So do this in class first thing. Okay? Alright, now we're going to look at how do we evaluate the function when we only have the graph. Okay? F of 2, it used to be f of x, and now it's f of 2. So that means that x is equal to 2. And so we want to know what is the y value for when x is 2. So this is my x-axis and this is my y-axis. So I'm going to go 2 units over 1, 2. And then I go up. It's right there, which f of 2 is 1/2. It's halfway up. Right, so f of 2 is equal to 1/2. Now if we evaluate it for these other ones, so I want to know what is this one when x is negative 2. So I'm trying to find out what is y. So I go 2 over, I go up to the graph, it was up 1, so y is 1. F of 1 wants to know when x is 1, what is y? So I go over 1, then I have to go down to find the graph, that's negative 1. Then I try to find out what is f of negative 1, so when x is negative 1, then what is the y value? So I'm going to go to the left 1. Oh, it's right there. So when I go left 1, I don't go up any, so it's 0. Now it also works backwards. Remember that f of x is also y. So when y is 2, what is x? So a y of 2 is up 2. Then I go across to find the graph. It's right there. And down to find my answer, 1, 2, 3. When y is 2, then x is 3. Alright, now it says given the following functions I'm supposed to write as an ordered pair. So it's f of x equals y. So whatever's inside here is the x, whatever's outside is the y. Okay, so all we're trying to do is now go back and write it as an ordered pair. So here the 5 goes first, comma, the 3 goes second. Here the negative 3 goes first, the 6 goes second. That's your ordered pair. X2 goes first, negative 2 goes second. Alright, now we're going to evaluate functions using ordered pairs. And this might look complicated, but it's really super easy. So we want to know f of x equals y. When x is 9, what is y? So 3, 6, oh, there it is right there, 9. When it's 9, it's 10. So f of 9 equals 10. Another example, if I wanted to find f of 12, I start going across here, 3, 6, 9, 12, there it is. So it's equal to 11. Okay. Here I'm supposed to complete the table using f of x is 3x minus 1. So because I don't have a calculator on me, I'm going to just use the old school method of plugging in. I'm going to take all these values one at a time. I'm going to put them right there beside that. So I get 3 times negative 2 minus 5. 3 times negative 2 is negative 6. Minus 5 is negative 11. I'm going to do the same thing with negative 1. 3 times negative 1 is negative 3 minus 5 is negative 8. Just plug in 0. 3 times 0 minus 5. 3 times 0 is 0. Minus 5 is negative 5. 3 times 1 minus 5 is 3 minus 5, or negative 2. And then the last one, 3 times 2 minus 5 is 6 minus 5, or 1. Then I'm supposed to find out what is f of negative 1. So I'll go right here. It's negative 8. Alright, here it says I'm supposed to complete the table of values, the mapping, the graph, and the ordered pair so that they all represent the same relation. So I have bits and pieces of all of it. So right here I find out that negative 3 goes with 2. So when x is negative 3, y is 2. Well, here I see 2. I can go ahead and put a negative 3 there. Here I can put a 2 here and draw to there. Okay. Let's keep going and see what else I have. And I also know that negative 4 and 1 go together. So I can connect that there. Negative 4 goes with 1. I still need to find out who goes with 0. Oh, I see it right here. Right there, 4 goes with 0. So I need to put 0. 0 is going to be way up here in my mapping. 4 goes all the way up there to 0. Now I need to find out who goes with 3. Oh, right here it is in my mapping. 3 goes with 3. 3 goes with 3. And then the one thing I haven't used yet is the table, or sorry, the graph. So let's go over here and see what this ordered pair is. This is negative 1, 2. So this point is negative 1, 2. So that's my missing ordered pair there. Negative 1, 2. Negative 1, 2. And negative 1 goes with 2. Now the only thing I haven't done is figured out the rest of my points here. So let's graph them. Negative 3, 2 is left 3, up 2, 1, 2, 3, 1, 2. Then 4, 0, so to the right 4, 1, 2, 3, 4. It's actually going to be off the screen there. 3, 3, 1, 2, 3, 1, 2, 3. Negative 1, 2, that was that one. And then negative 4, 1, 2, 3, 4, down 1. Okay. So then I'm supposed to find out what's f of negative 1. So I know the x, what's the y? So when I get an x of -1, it's 2. Something else to look at, is this a function or not? We can look down through here and see if we see any repeaters. We can also do the vertical line test here. Let me get a different color. Vertical line test here. And in all cases, this is a yes. This is a function. That's it.